Hey everybody, this is Professor Johnson getting back to you on our Collier and Evans case study for this week on the David Christopher orthopedic surgeon case. So what I'm going to do is walk through with you some of the formulas from Chapter 10 that apply to this case, and then walk through the details of the case so we can see how this all played out. So what we have on the screen here right now are the two key formulas from Chapter 10 that apply to this case. So these are taken from pages 210 and 211 in Chapter 10. The first one is the capacity requirement for the individual worker. And here is the formula, right? So CI equals SI plus PI times QI. Here's what each of those terms mean. CI is our capacity requirement for work order I, so whichever work order that is, we'll just call that I. The capacity requirement for work order I is a function of the setup time or changeover time for that work order plus the processing time for each unit of the work times the quantity of the order in number of units. Note that in this capacity requirement formula that the setup time does not vary with volume. So if you think about that from a manufacturing perspective, you do your setup once at the beginning of the run for running that order, and then your order continues to run. So then it's just going to be a function of the processing time times the quantity of units in your order. You add those numbers, which obviously do vary based on quantity, to this single setup time, and you have your capacity requirement for an individual work order. So then to get the capacity requirement for your total shop, it's a pretty simple thing. You just want to add up all the capacity requirements for the individual work order. It's just the sum of those things. And you have your capacity requirement for the shop. So those are the basic formulas from Chapter 10 that apply to our case at the end of the chapter, the David Christopher case. I've set up some spreadsheets here with some information already populated just to speed this video, and so I won't. You don't have to waste time watching me set these up. So here we have our formulas still here. And now here's the basic spreadsheet, data sheet, or data set from the case. We've got the orthopedic procedure here in this column. We have the changeover time in minutes. In the second column, surgery time in minutes. Third column, each surgeon, Dr. A or Dr. B. In the fourth column, and then finally, the demand or the number of patients that are scheduled weekly. So that's our basic setup. I've added a line here that we're going to fill in eventually with looking at the total capacity requirement for each of these for these procedures. All right, so now let's go and figure out what else we're going to add to this to start responding to the questions at the end of the case. So the first is that we need to figure out the capacity required for each process, right? This is a little bit tricky in this particular case based on the text in the case. So in theory, we should be using our capacity requirement for the individual work order to calculate the capacity required for each of these processes, right? We can consider these an individual work order in this service environment. Well, what we do know, though, from the case is that this item here, which would be our change-up or setup or changeover time, is a recurring item that actually does vary with volume. Because recall that Dr. Christopher and his colleague use this changeover time in between each surgery, and they do that for a variety of reasons. Not the least, and maybe the most important of which, is to guarantee or help facilitate the quality of the surgeries. So this changeover time in this particular case does vary with volume, which means we need to change our formula a little bit, right? So our capacity requirement for an individual work order now changes. It is the setup time plus the process time times the quantity or the demand. So we've changed that a little bit for this column. These columns here, capacity required for surgeon A, capacity required for surgeon B, since we have these surgeons labeled separately, and we may need this information may be useful as we consider questions 2, 3, and 4. These will populate these columns as well. And then we'll get totals down here. So let's put some formulas in and see what this looks like. So we've put this formula in here. This is what it looks like in Excel syntax. We've just copied that down then to all the subsequent cells, and we come up with these numbers. So you can see in a couple of cases where, and this would not have been the case if we utilized our original capacity requirement formula, that we've got some zeros here. And those zeros are, for obvious reasons, there are no orders, right? So no orders, we're going to have some zeros there. And then these capacity for surgeon A, capacity for surgeon B, we just transferred whatever is in the appropriate cell here over to this cell. Here is the syntax in Excel for that. So now we know that our total capacity requirement, right? Total capacity required. Here we have our C equals the sum of all the individual processes, is 2,415 minutes in a week. And for surgeon A, it's 1,285 minutes, and for surgeon B, it's 1,130 minutes. So we've got the breakdowns now of the capacity required for each process and the capacity required for the total practice, the total surgery practice. So now some additional information will be useful as we start to think about answering questions 2 and 3 and 4 in our case. We need some more information about the total amount of surgery time that's available based on the information in the case. So we know what's required based on demand, and this is our requirement, total capacity requirement, right? But we don't know what's available yet. So let's take that data from the case and figure that out. So we know we have 2 surgeons. We know we have 4 surgery days per week. They don't operate on Fridays. We know we have 5 hours of surgery time each day. And so our gross surgery times per minute per doctor, gross surgery time in minutes per week per doctor, is 1,200, right? So here's all we did was take and convert the hours here into minutes. So if we look at the syntax for this particular cell, it's 60, right, for 60 minutes times B31 times B30. So B31 times B30, and we get the 1,200 minutes. All right. So now we also know from our case that there is a safety capacity, right? And they like to keep 10% of their available surgery time open for emergencies and other unexpected factors. So we keep that 10% open, times, we'll put that as 10.1 here. And so we multiply our total surgery time per doctor times our 10%, or we subtract the 10% rather, and we end up getting 1,080 minutes. That's the net surgery minutes per week per doctor that we've got, right? And again, here's the syntax for that cell. So that gives us then, if we multiply that times 2, 2,160 minutes per week for the total surgery practice. So now we can start to compare that to the requirements and figure out what we've got going on. So let's put another little table in here. We've got the capacity required, which we know from our previous calculations. We have the capacity available, which we know from the calculations we just did. So now it's just a simple matter of subtraction, and we know how much we're either excess or short for the practice, actually, and it would go the same for on average for each of the surgeons. So we know that we are short now about a quarter, 0.25%, about a quarter of a surgeon, right? Given the parameters that we have in the case, we need another quarter of a surgeon to meet the demand that's required based on our calculations up here and the work that Dr. Christopher did. So that sets us up now to talk about questions 2, 3, and 4. What are we going to do about that? What are we going to do now from a management perspective, from an operations management perspective, addressing this? Clearly, Dr. Christopher and his colleague are overburdened. There's more demand than there are resources. So what are the options in terms of either hiring another surgeon, reworking maybe days off, maybe they don't take every Friday off, maybe shortening the changeover times, but do you really want to do that? And when part of that time is for rest for the surgeons. So there's all sorts of issues to consider here as we think about questions 2, 3, and 4. And we'll talk about that online and in class.